Hi everyone. So now I am going to explain suprafacial and anterofacial shifts or selection rules for the 1J shifts or IJ shift. Now I am taking 4 electron system hydrogen or axis atom shift. Example 1,3 proton shift, where the proton is shifting from the first position to third position. So that's why it is 1,3 proton shift. So there are two cases arises. They are suprafacial and anterofacial. In the suprafacial case, the proton is linking in the lower phase, and in the anterofacial the hydrogen is linking with upper phase. In thermal condition, 1,3 suprafacial hydrogen shift. Now you have to select HOMO from the ground state configuration as Psi1 has 2 electrons, Psi2 has 1 electron, Psi3 is equal to 0, where Psi2 is the HOMO. Psi2 molecular orbital is HOMO for the above system. The new interaction is developed where that is anti-bonding interaction, thermally forbidden. Next, 1,3 anterofacial hydrogen shift. 3 carbons and hydrogen having positive charge, where the bonding interaction is developed between the first carbon and hydrogen, where Psi2 is the HOMO ground state configuration. Bonding interaction is developed, therefore thermally allowed. But in the photochemical condition, first you have to select the HOMO from the first excited state. Psi1 has 2 electrons and Psi2 has 0, where Psi3 has only 1 electron, therefore it is HOMO for the photochemical condition. Now we are writing 1,3 suprafacial hydrogen shift. The hydrogen is shifting from the first position to third position, where the bonding interaction is developed between the first carbon atom and hydrogen, therefore it is photochemically allowed. But 1,3 anterofacial proton shift, anti-bonding interaction is developed, photochemically forbidden. So it is for the 4n system. Now we are going to discuss 4n plus 2 pi-electron system for the atom shift, 1,5 shift. Suprafacial and anterofacial configurations are possible for the 1,5 shift. The proton is shifting from the first position to fifth position. In the suprafacial, the hydrogen is linking in the lower phase. In the anterofacial, the proton is linking on the upper phase. The thermal conditions for the 4 electron system. First, we select HOMO of 2,4 pentadienyl radical from the ground state configuration. Psi1 2 electrons, Psi2 2 electrons, Psi3 1 electron, Psi4 0, Psi5 0, where Psi3 is HOMO. Now you have to take HOMO as Psi3 molecular orbital. For the 1,5 suprafacial hydrogen shift, the bonding interaction is developed between the first carbon and hydrogen. So that's why it is thermally allowed. For the 1,5 anterofacial hydrogen shift, where the anti-bonding interaction is developed, therefore thermally forbidden. Now we are explaining photochemical conditions for the 4n plus system. In the first excited state, we have to select HOMO. For the above example, Psi1 2, Psi2 2, Psi3 0, Psi4 1, Psi5 0, where Psi4 is HOMO. Now we are writing 1,5 suprafacial hydrogen shift. The proton is shifting from the first position to fifth carbon. So therefore, the anti-bonding interaction is developed between the hydrogen and fifth carbon. Therefore, it is photochemically forbidden. In the 1,5 anterofacial hydrogen shift, the bonding interaction is developed between the hydrogen and carbon. Therefore, it is photochemically allowed for the 4n plus 2 system, where the group is shifting from one position to another position is called shift rearrangement. Now we are taking one example, C double bond C and C. At first position we have some group. The group shifting from first carbon to third carbon. That's why it is 1,3 group or 1,3 shift. If suprafacial configuration, the inversion configuration is retained in the product, and also the retention of configuration also retained in the product side, because of the D is on the right side. If D is on the left side, retention of configuration for the suprafacial. If we write the anterofacial configuration for the above example or 1,3 shift, the anterofacial inversion configuration and retention of configurations are possible for the antifacial. Now we are writing the thermal conditions. First you have to select HOMO of the allyl radical from the ground state. Psi1 has 2 electrons, Psi2 has 1 electron, Psi3 is 0. Now we are writing 1,3 suprafacial group shift with retention of configuration. In earlier topic we discussed only hydrogen atom or oxygen atom shift rearrangement. Now the group is shifting or migrating from the first position to third position. Therefore the anti-bonding interaction is developed between the group and the first carbon. Therefore thermally forbidden. In inversion, rotate lobes in the transition state with 90 degrees. D is vertical, after that one more 90 degrees. In 1,3 antifacial group shift with retention of configuration. In this case also a bonding interaction is developed, therefore thermally is allowed. For the 1,3 suprafacial group shift with the inversion of configuration, bonding interaction is developed where thermally allowed. 1,3 antifacial group shift, inversion of configuration where the anti-bonding interaction between the negative and the positive signs obtained, therefore it is thermally forbidden. In the case of photochemical condition, the HOMO for the allyl group and first state configuration Psi1 2, Psi2 0, Psi3 1, where Psi3 is HOMO. The suprafacial group shift, retention of configuration, therefore bonding interaction is developed, it is photochemically allowed. In the case of antifacial group shift, retention of configuration, anti-bonding interaction is developed, photochemically forbidden. Suprafacial group shift, inversion of configuration, anti-bonding interaction and photochemically forbidden. So it is the group of the carbon system. So 3 carbon atoms present in the 1,3 system. And in the next case, antifacial group shift, inversion of configuration, bonding interaction developed, therefore it is photochemically allowed. So these cases for the 4n system. Now we are going to discuss 4n+2 system for the group shift. Best example is 1,5 group shift. So in 1,5 group, the group is shifting from first position to fifth position, then it is called 1,5 shift or 1,5 group rearrangement. So at the fifth position the group is attached. Thermal conditions for the 4n system. First you have to select HOMO of the 2,4 pentadienyl radical from the ground state configuration Psi1 2, Psi2 2, Psi3 1, Psi4 0, Psi5 0, where Psi3 is the HOMO. For the suprafacial group shift, retention of configuration, bonding interaction is developed, thermally allowed. And in the antifacial group shift, retention of configuration, the anti-bonding interaction is developed, thermally forbidden. Suprafacial group shift, inversion of configuration, the anti-bonding interaction because of the node is possible between the positive and the negative sign, thermally forbidden. In the case of antifacial group shift, inversion of configuration, the bonding interaction is developed between the group and the carbon chain, thermally allowed. In the case of photochemical condition, first we have to select HOMO from the first excited state configuration Psi1 2, Psi2 2, Psi3 0, Psi4 1, Psi5 0. In the suprafacial group shift, retention of configuration, anti-bonding interaction is developed, therefore it is photochemically forbidden. For the 4n+2 system in the photochemical conditions. In the antifacial group shift, retention of configuration, bonding interaction is developed, therefore photochemically allowed. Suprafacial group shift, inversion of configuration, bonding interaction is developed. Suprafacial means same side of lobes, inversion of configuration, photochemically allowed. Antifacial group shift, inversion of configuration, anti-bonding interaction is developed, photochemically forbidden. So finally we are concluding 1,3 and 1,5 group shift. So first we have to write selection rules for the proton shift. For the 4n system, supra 1,3 shift, antara 1,3 shift, supra 1,3 proton shift, antara 1,3 proton shift. photochemically allowed, thermally forbidden. Thermally allowed, photochemical forbidden for the anti-Ra 1,3 proton shift, and photochemically allowed, thermally forbidden for the supra 1,3 proton shift for the 4N system. And last one, thermally allowed, photochemically forbidden for the anti-Ra 1,3 proton shift of the 4N system. Now for the 4N plus 2 system, supra 1,5 proton shift, supra 1,5 proton shift, both are thermally allowed and photochemically forbidden. And final one, anti-Ra 1,5 proton shift, anti-Ra 1,5 proton shift photochemically allowed and thermally forbidden for the 4N plus system. So these are the selection rules for the proton shift, and this is the IJ or 1J shift reactions for the pericyclic reactions. Thank you.